In this lesson, we are going to take what we know about solving 1- and 2-step equations to solve multi-step equations. In order to solve multi-step equations, we must first simplify the equation. And remember, to simplify an equation, we first complete the distributive property. And remember, we only do that if needed. So only if we have parentheses with a number directly in front of that parentheses. Second, in order to simplify an equation, we want to complete the combining of like terms. If needed. So remember, like terms have to have the exact same variable with the exact same exponent, or they both have to be constants. Finally, once the equation is simplified, we solve it, just like we solve 1- and 2-step equations by doing the opposite operation. So let's take a look at some examples. Number 1, we can see that there are no parentheses, so we do not have to do the distributive property. So then next, we need to check to see if we can combine like terms. I can see that I have a 9x minus 7x. 9x minus 7x is 2x. Then I can see I have a 1 minus 5. 1 minus 5 is negative 4, equals negative 20. Now that this equation has been simplified, I can solve it like a 2-step equation, doing the opposite. Remember, getting rid of addition and subtraction first. So instead of minus 4, we're going to add 4 to both sides, which leaves us with 2x equals negative 16. Our variable is not isolated yet, so we need to get rid of the 2 in front of x. So remember, 2x means 2 times x. So to eliminate that 2, we're going to divide by 2 on both sides. I'm going to move my work over here. So we have 2x divided by 2 equals negative 16 divided by 2, which is x equals negative 8, because negative 16 divided by negative 2 is negative 8. Remember, with all equations, we can take that answer and we can check it. So we can take negative 8 and we can plug it back in for x, everywhere there's an x. So 9 times negative 8 plus 1 minus 7 times negative 8 minus 5 should come out to negative 20. That's negative 72 plus 1 plus 56 minus 5 equals negative 20, which is negative 71 plus 56 minus 5 equals negative 20. And it comes out to negative 20 equals negative 20, which is true. So then I can say that x equals negative 8 is my final answer. Let's take a look at number 2. Number 2 does have a set of parentheses, so we need to distribute. Remember, we distribute the number directly in front of parentheses. So the negative 7 is going to be distributed to the 3a and to the negative 1. So we have 91 equals negative 21a plus 7. Remember, when we distribute, we're multiplying. We're multiplying that number outside the parentheses times everything inside. Now, when it's like this, we can solve it the way it is, but a lot of times for students, it's a lot easier to see that variable on the left. So if you want to rewrite your equation as negative 21a plus 7 equals 91, you can. Because you're switching the whole equation, you're just flipping the left and right side, you do not have to change any signs. Once it's written this way, a lot of times it's easier for students to see that addition and subtraction first. So instead of plus 7, we're going to subtract 7 from both sides, which leaves us with negative 21a equals 91 minus 7 is 84. Then, to get rid of negative 21, remember negative 21 times a, so instead of times negative 21, we're going to divide both sides by negative 21. Which leaves us with a equals 84 divided by negative 21 is negative 4. Then I can take that answer and I can check it. So 91 equals negative 7 times 3 times negative 4 is negative 12 minus 1. 91 equals negative 7 times negative 12 minus 1 is negative 13. 91 equals negative 7 times negative 13 is 91. So when we checked it, we got the left side equals the right. So we know that our answer of a equals negative 4 is true. I want you to go ahead and highlight number 3, and let's take a look at number 4. Number 4, you can see we have 2 sets of parentheses. So I wanted to look at this problem with you for 2 reasons. One of those reasons was because it has 2 sets of parentheses, so we're going to have to distribute twice. The other reason is that second set of parentheses, the number directly in front of that parentheses, there's not really a number there, there's just a minus sign. So remember, what that means is there's an imaginary negative 1 there. So when we go to distribute in just a minute, you will distribute a negative 1. And if you need to write in that negative 1, you can. For some students, it'll help you remember to distribute a negative 1. So let's start by distributing the negative 3. Negative 3 times k is negative 3k. Negative 3 times negative 8 is a positive 24. Now here's the part. This is a negative 1 getting distributed to k and 5. So negative 1 times k is negative k, and negative 1 times 5 is negative 5, equals 23. So from here, I no longer have my parentheses, so I need to check to see if I can combine like terms, and I can. I can start by combining negative 3k minus k. So remember, there's that imaginary 1 there. So that's negative 3 minus 1, which equals negative 4k. I can also combine all of my constants. So 24 minus 5. 24 minus 5 is a positive 19, equals 23. So now that my equation is simplified, I can solve it like a 2-step equation, starting by getting rid of the addition and subtraction first. So instead of adding 19, we are going to subtract 19 from both sides, which leaves us with negative 4k equals 23 minus 19 is 4. Then I'm going to move my problem up here to give me a little more room. So negative 4k equals 4. I just rewrote the problem. When solving an equation, your variable must be isolated. So we need to get rid of the negative 4 attached to the k. And the operation that separates those two is division. So we're going to divide both sides by negative 4 because negative 4 is the number we're trying to get rid of. Negative 4k divided by negative 4 is k, equals 4 divided by negative 4 is negative 1. So I have a final answer of k equals negative 1. And remember, you can take this and plug it back into your equation to check to see if your answer is correct. Go ahead and highlight number 5. Highlight number 6 and number 7. And let's take a look at number 8 together. Number 8 has a fraction in it. That's why I wanted to look at it with you, because a lot of times we get a little frazzled when we see a fraction in a problem. But just remember, we solve it the same way. And when we have a fraction and we multiply, we just multiply straight across. And hopefully, once we distribute that fraction and multiply, it'll go away. So I have negative 25 equals, so 1/2 times 10x. I'm going to come over here to the side so you can see this math. So 1/2 times 10 over 1. Multiplying straight across, 1 times 10 is 10, and 2 times 1 is 2. 10 divided by 2 equals 5. So 1/2 times 10x is 5x. Then 1/2 times negative 2. So again, I'm going to show you that math over here to the side. 1/2 times negative 2 over 1. 1 times negative 2 is negative 2. 2 times 1 is 2. Negative 2 divided by 2 equals negative 1. So when we multiply 1/2 times negative 2, we get negative 1. And then don't forget your plus 3x outside the parentheses. We just bring that down. Now again, this is a step where if it helps you to see the variable on the left, you can completely flip your left and right side and write it as 5x minus 1 plus 3x equals negative 25. So once we've distributed, we need to check to see if we can combine like terms, and in this problem we can. We can combine 5x plus 3x. 5x plus 3x equals 8x. There's nothing to combine minus 1 with, so we're going to bring that down, equals negative 25. So now I have a two-step equation that I can solve. We're going to solve it by adding 1 to both sides. Remember, we're doing the opposite. So that's 8x equals 25, or negative 25 plus 1 is negative 24. And then divide both sides by 8. So that we get x equals negative 3. And remember, you can take that, plug it in for x everywhere there's an x in your original problem, and if your left side equals your right side, then you know your answer is correct. Go ahead and highlight number 9, and then I want you to highlight the challenge problem. The challenge problem simply wants you to translate it to write your own equation and then solve.